Hello, this is Mr. Opelia, and this is for the distance learners. We did this in class, so this is for you if you are distance, okay? So we did this project right here. It's called Periodic Table Basics. It is something that you will follow the directions, and if you follow directions, you will create. Okay, and on top you can put your title of it. You can put your name and call it the periodic table, whatever you'd like to do. Notice that it's a small version of the periodic table. Okay, and you can watch this over and over so that you can kind of like um, have something to go by when you're doing this. Okay, so I'm going to show you a little bit on how to do that right now. I'm going to have this in the office for you to pick up, for your parents to pick up. Hopefully they can do that. So here is this. This is the instructions, and you see step 1 right up here, and step 2, step 3, step 4, step 5, step 6. So what you do is inside here, if you turn it to the inside, you will find these squares, and there are 18 total. I will open up the second one to show you. Here's the other 9. Okay. Okay. Notice they are little squares like the ones on the periodic tables. See? Here's neon, phosphorus, hydrogen, magnesium, carbon, lithium, boron, helium, sulfur, and so on. Okay. So that's what these little squares look like. So what you're going to do is on each one, while looking at a periodic table, and you can use any that you want on the internet if you wish. I can include one in this packet for you. So you're going to fill out each little square. So here is a sample one, right? So here they just have a sample of how you do it. So you're going to fill out these squares just like they would be on a regular periodic table, at least this section right here. Then they're asking you again how many protons there are in this atom, how many neutrons, and how many electrons. And then they want you to draw the electrons on a Bohr model. And a Bohr model is just showing the electrons that are on the energy rings, okay, around the nucleus. So as you look at this, you notice for boron, there are 5 protons because the atomic number is 5, right? Symbols B, name boron. Here's the atomic mass. So here we have, if there's 5 protons, there are 5 electrons. They equal each other always, okay? All right, then you have 5 electrons to put on this Bohr model. Okay, so you always put 2 electrons. The first 2 go on the inside circle. We talked about this earlier in the year. And then the rest will go on the second one. So since boron has a total of 5, that's how you would do boron. If we had an element with a total of 8, you would still put the first 2 on the first ring on the inside, and then you would put 6 around on the second ring, because there's can only be a total of 8 on the second ring if there are multiple numbers of electrons. Okay? The only rule is 2 on the first ring, 8 on the second ring, and up to 8 on the third ring if it happens to be. Okay? Then we have the Lewis structure, which is right here. This is not difficult. The Lewis structure is you put dots around the symbol that are the electrons on the outside ring. I'll say it again. The electrons on the outside ring, for instance on boron, if you look, there are 3 on the outside ring, right? 3, 1, 2, and 3. So you will put on the symbol portion, you would put 3 dots around that letter, and that's called the Lewis structure. It's just talking about the valence electrons, which are the outside rings. I'll show you an example of one inside here that you would be doing to show you the how that looks. So here we are. Now you're going to be doing these just like that sample one, right? So here you would have fluorine. You would have up here, you would have the atomic number of fluorine once you look at the periodic table. Then you would have the name fluorine on the second one. You would have the atomic mass for fluorine. Of course, you find that in the on the periodic table, I mean, right? And then over here, you're going to put the number of protons for fluorine, which equal the atomic number, and then the number of electrons, and then you have the Bohr model. And that's the number, that's the electrons that are for fluorine. Okay, so that's how you do it, just like this sample on the front. Remember the 2 electrons on the first ring, and then you would go up to 8 if you need to on the second ring, depending upon the total number. Then down here for the Lewis structure, you have only the number of dots around F as you do for the outside ring, right? So you would have to, each one is going to be different. Next, one thing I didn't mention is the neutrons. To find the number of neutrons, the way you find the number of neutrons, and we did this earlier in the year, is you take the atomic mass for that element, whatever that might be, you round it to the nearest whole number. So if the number was 14.23, the nearest whole number would be 14. You take 14, you minus the atomic number, and whatever you have left is the number of neutrons. So let's just, as an example, if fluorine was if fluorine was the atomic number 7 and mass was 14.23, that would be on this line right here, 14.23. I would round 14.23 to 14. I would subtract 7 from 14, and the number of neutrons, 7. This is just an example. That is not the true answer for fluorine. It's just an example. So listen to this recording over and over. You will be able to do each of these individual squares, okay, and put the correct number and electrons on the rings. Now, after you have done that, after you have done it for each of these squares, there's 18, while looking at the periodic table, then look down here and you will see step 5. Use the following colors to shade in the square for each element, okay? You should only color the small square in the upper left-hand corner and not the entire card. So here we have green. Use a green colored pencil for lithium and sulfur. You see this? Lithium, the symbol Li, sulfur, Na, right? Use green colored pencil. And as you see here on the finished product, lithium is green just in the little square, and sulfur is green in the little square. Notice and look at these. You can see how they're done. Notice this person, this is a student's. They did the Bohr model for lithium. They did it correctly. They didn't do it correctly, excuse me. This has only 1 electron on the outer shell. There should have been only 1 dot. And here beryllium has a total of 5 electrons, and they should have had 3. So this isn't bad to show you the wrong way, because that might happen to you. Here, boron, this has, looks like this has 5. Oh, they got some. Anyway, this one has 5, and there's 3 on the outside, so they put 3 dots. Okay, So anyway, let's look at this one right here. Let's check this one out. So we have 10 protons, we have 10 protons, 10 neutrons, and 10 electrons. So what did they do? They put 2 electrons on the first shell, and on the outside, they put 8. That equals 10 electrons. Perfect. For the Lewis structure, they should have 8 dots around this symbol. And they do. They have 8 dots around the symbol. Good job, whoever did this one. Okay. All right. So if you have any questions, let me know. But that is this one that you're going to pick up, and I'm going to also give you a white sheet. Okay? All right.